Alright, just a reminder that you do need to watch the video in its entirety. You can watch it multiple times. And your yellow packet for all classes is due the day of your test. I expect work in the yellow packet and not just answers. Alright, so first of number 1, we have a regular hexagon. So I would maybe make a note that regular means, oh gosh, that's not what regular means. Regular means all sides equal and all angles equal. Okay, so if we're going to label all of the congruent sides and all the angles, we are just going to put tick marks on all the sides, and we are going to put little parentheses on all the angles. Okay? Alright, so because it's regular, we can do that. So what theorems or definitions do we need to know to label the congruent sides and angles? Well, that would be definition of a regular polygon, because that definition tells us all your sides and all your angles are equal. Definition of a regular polygon. Okay. Alright, and then they want us to decide if triangle FAB, I'm going to make this a little smaller, is congruent to triangle CBA. So hopefully you realize that they are an overlapping triangle. So a strategy we utilize is to redraw the triangle. So if I redraw FAB, this would be FAB, and then our blue one was triangle CBA. Alright, and then let's mark what we've already marked. So we already marked side AF congruent to side BC because those were sides of your regular hexagon. Then you can see that segment AB is repeated, so that's congruent to itself. And we also already marked this angle up here because that's an angle in the hexagon, and this angle right here. So I would definitely use side, angle, side. Okay? Alright, triangle SAB has side lengths 5, 10, and 14. Which transformation will produce a similar triangle? So we definitely want to be similar to SAB. Select all that apply. That definitely means it has more than one answer. So similar is when you multiply or divide. So all the ones that have multiply or divide will produce similar triangles. Adding or subtracting will just be congruent. Alright, number 3, which statements are true for all parallelograms? Select all that apply. So definitely has more than one answer. If you're looking at your notes, you should be looking at properties of parallelogram notes. That will tell you diagonals bisect each other. There is line symmetry. This is referring to one line of symmetry, and we have discovered that there will never be one line of symmetry, so B does not count. Opposite angles are congruent. That is a property. Rotation symmetry of 180 degrees. Opposite sides congruent. Exactly one pair of parallel sides. We have two pairs, so that is not. Diagonals are congruent. That is not true. And consecutive sides are supplementary. That is not true because consecutive angles are supplementary. Okay? So the properties that we definitely know are the diagonals bisect, opposite angles are congruent, 180 degree rotation symmetry, opposite sides are congruent. Right, I think this is the last question on this page. All right, number 4, we have this figure, and what congruent angles or sides will give us sufficient information to prove triangle KLM is congruent to triangle OML, and they want us to use the AAS theorem. Okay, so the first thing we're going to need to do is redraw. Okay, so KLM, and notice I try to make them going in the same way, but it's just a sketch. Okay, so this is OML. Okay, and they are telling us, they told us that those big angles were congruent. Okay, and you should see that segment LM is congruent to segment LM because it's in both triangles. So if we want to use AAS, our angle needs to be away from the side. So you would definitely want to choose angle K, because that would give you an angle, and a side. And angle K needs to be congruent to angle O. Okay, number 5 is a man standing 3.6 meters from a 6-meter flagpole casts a 2.8 meter flagpole. How tall is the man? To the nearest tenth. So you're going to need to watch how I round. So I would make a man and his triangle. And then I would make the pole and the pole's triangle. So this is a similar triangle question, so we're going to need to set up a proportion. The pole is 6 feet high, and its shadow is 3.6 plus 2.8, which is 6.4 meters. And then the man, we don't know his height. What we know his shadow is 2.8. So you can, and these are right angles, you can set up a proportion with x over 2.8 equals 6 over 6.4. And then you cross multiply. So if you do this problem and you don't understand how to cross multiply, I would definitely see me, because I'm not going to show you. You just kind of 6 times 2.8, and then that gets divided by 6.4, and you get 2.625. You will not get that correct on your test because it says round to the nearest tenth. So 2.6 meters is how tall the man is. Okay? Alright, number 6. If triangle PSV is similar to triangle PVH, what is the length of segment PS? So I know it does not tell you which one is the image and the pre-image, but you might as well just pick one. So you're consistent with always doing image over pre equals image over pre. Okay? So the side that we are trying to find is segment PS, and you can see that PS corresponds to BF, so that's your first proportion you can set up. PS is in the image over 5.4. And then we want to pick another side. I would pick PV, and PV goes to side BH. So if we're consistent with image over pre-image, it has to be 11.5 over 9.2. And then again, you cross multiply. If you cannot cross multiply, please see me. Okay, divided by 9.2, 6.75. So notice this one does not say to round anywhere, so you can just leave your answer as 6.75. If it doesn't say to round, just use what's in your calculator. Alright, then it wants the measure of angle F. Well, the angle measures stay the same, so what I would do is match up F to S. Sadly, we don't know S either. But we know V is 33 degrees, so that means H is 33 degrees, and then you just need to find the missing angle of a triangle. Add up what you know, and then subtract from 180, because that's the sum of the interior angles of a triangle. So I found the measure of angle F is 63 degrees. Okay? Alright, so remember, I have shown a lot of work. In order for you to get the most out of this video, you can either follow along and show the work, or do it and then check the questions with the video. Okay? Alright, so look at parallelogram at the right. I'm going to label my sides. 2x plus 12. So this was probably a quiz question where it said to explain your thinking using mathematics and justifying. So the first thing we know is if we want to find x, we can set these equal, and I'm going to tell you why in case you have to justify on your test. Opposite sides in a parallelogram are congruent. So yes, a lot of you did that, but you didn't tell me why. And if it says explain or justify, you need it to say why. Okay? So from here, if you cannot solve this, you really need to see me, because at this point in your geometry careers, we should be able to solve a multi-step equation. And 15 equals x. And then I want to go back and double check, did the question want x or did it want a side length? And lucky for us, find the value of x, so we found the value of x. Alright, in the diagram below, dog is the image of cat. Okay, so we go from our pre to our image. What is the value of k? K is the image side over its corresponding pre-image side. It's its magnitude, how much we multiplied to each side to get to our image. So I would just pick a side that you know. CA over DO. Just kidding, because we want to do image over pre-image. So we would do 1.4 over 3.5. You definitely want to key that in your calculator. 1.4 divided by 3.5. Enter. You can leave your answer as 0.4, or you could hit math, enter, enter, and leave your answer as 2/5. Either one would get credit, but you definitely want to simplify your answer. Okay, suppose segment RS is a segment with a slope of 5/7 and a length of 15 units. Segment R prime S prime is the image of segment RS under a size transformation of magnitude 3. What is the slope of the primed image? Well, there are a lot of numbers here and a lot of information, but during a size transformation, slope doesn't necessarily change. So your slope is still going to be 5/7. Okay? What triangle congruence theorem can be used to prove that triangle TUV is congruent to triangle YWX? Okay. So, first, you definitely want to make sure all your angles match up so we can even say they're congruent. So I'm going to just find angle U real quick. 48. So this is 149. 180 minus 149. 31. Okay. So this guy has to be 48. So now I'm just going to look at one of the triangles. So if I look at one of the triangles, I can see that I have an angle, a side, and an angle. And then I also have an angle, 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 side. So this could be a select all that apply type problem as well. All right. Okay, number 11. Using only the given information, what triangle congruence theorem can be used to prove that these two triangles are congruent? So what I would do is I would make triangle ESH a color and label that piece of information. So angle E is 42 degrees. Notice I'm putting the angles on the inside, the sides on the outside. Alright, and they want that to be congruent to triangle ABC. So I'm just going to line up my letters to make sure A is in the same place as E. Okay, 42 degrees, 67 degrees, and 4 centimeters. So right off the bat, we know we have two angles. And if you look, your side is actually in between those two angles. So we have to use angle, side, angle. Okay, number 12, use the given information to mark the diagram. So we are given that side CD is congruent to segment AB, and angle B is congruent to angle D. Now, if you remember, Ms. Luce said this looks like a bow tie, so that means you need to be on the lookout for vertical angles which happen to be equal. So now we can see we have an angle, and a side. Going on to properties of parallelograms. Okay, so LP and PN, those are diagonals. So this is the property you're going to use. Diagonals bisect each other. So that means they equal. Each part equals the other part. So 9x plus 12 equals 3x plus 36. Solve for x, 36 minus 12. X equals 4. Okay. Now we have angle LON, which is this whole angle here, is 65 degrees. And angle MNO is 5y degrees. So these are same side angles, which means they're supplementary. So I'm just going to write that property down, which means they add up to 180 degrees. So 180 minus 65 divided by 5. Whoa, that's not right. Got y equals 23. But I don't think that's right. Let me just do another double check. 180 minus 65 divided by 5. Ah, I'm right. Okay. All right. Last but certainly not least, on the parallelogram, we have side LO and side MN. Well, those are opposite sides, and as we did in our other parallelogram problem, opposite sides are congruent, which means we can set those two expressions equal to each other, and we get 49. Sorry. Divided by 7. I also got W equals 4. Okay? All right, now something I will be checking on your practice test is this. All you have to now do is substitute in. Okay? So use your values to substitute into these expressions. But keep a note that angle MLO is opposite angle MNO. So if you can find MNO, you can find MLO. Angle MNO is 5y. Okay? So now I'm just going to be checking as you turn in your practice test that you actually did a problem on your own. Alright, 14. Let S be a size transformation with magnitude 3/4 if the distance between C to D is 25 and the size change applied to AB equals CD. So we do not know AB, so 3/4 are unknown, has to get us to 25. So to get rid of that 3/4, you just multiply by its reciprocal. So so times 4 over 3. So 25 times 4 divided by 3. Ugh, ugly number, but we're going to round it to the nearest tenth. Or you could write it like this. All of these would be accepted on your test. Okay? All right, number 15 is an easy peasy one. Triangle FAB is congruent to triangle CLR. Just cross out that question mark. What segment is congruent to AB? Match up your letters. This would not get you full credit because that's not a segment, that's a distance. In order to get the full points, you'd have to have the segment symbol overhead. Okay? 16. In the diagram, quadrilaterals FBAG are rectangles, which means you got right angles here. Right angles, right angles, right angles. Okay? Oops. CDEF is also a rectangle. FBAG, 90, 90, 90, which means this angle is also 90. Okay, so they want the length of DE. So this is actually going to be a similar triangles question. I want you to make a note that this is your right angle that we're going to pay attention to, and so is this. Okay? But if we pull out triangle CDE, our right triangle is in the upper right, okay, or our right angle. If we pull out this guy, triangle CBA, the right triangle is in the bottom left. So what I'm going to do is I'm going to try to show you how I would turn this triangle so that now my right angle is actually facing the same way as my picture up here. And I know the distance from C to B is 3. And technically you know this because the whole thing is 12, and you know 7 is a part of it. So 7 plus 5 gets you to 12. So from B to A is 5. And now you have a similar triangles proportional question. So you could do 12 over DE equals 5 over 3. So there's other ways to do this as well. This is just the way I decided. But you'll get the length of DE is 7.2. Alright, 17, they want us to prove this right here. So remember, we do not mark what we're trying to prove, but we have overlapping triangles. So we are dealing with triangle CDA, because that's one we're trying to prove. CDA. And then we have triangle CBE. Alright, so now I'm going to mark my given information. I know side CB is congruent to side CD, and I know side AC is congruent to side EC. And I look for repeated letters. There's one letter that is repeated, so that means you have an angle that's congruent to an angle. And now I'm ready to write my proof. So your first conclusion, everybody should always get right. You just write down exactly what the given says, and you justify that with given. So the other piece of information that we marked is that the given didn't come out and say is we need to mark angle, or we need to say angle C is congruent to angle C. And I'm actually going to use 3 letters just to be fancy, and I think you should as well. So ACD, that's the top one right there, is congruent to angle ECB. And when something is congruent to itself, that is the reflexive property of congruence. And now we have one of the triangle congruence properties. So now we're ready to say our triangles are congruent. And if you look at your picture, you can see that you had SAS congruence. Okay. All right, last page here. So I'm just going to get started, and I'm going to start writing whatever my given is. So segment FD bisects an angle EDG, and the length GD is equal to the length of ED. Given. Alright, so we are trying to prove that the two triangles FED is congruent to FGD. So I'm definitely going to mark that. Okay, then you want to look, is there anything shared? And side FD is in both triangles, so I'm going to come down and conclude that. And when something is congruent to itself, that is the reflexive property of congruence again. All right, and then I want to deal with this angle bisector. So angle bisector splits the angle in half. So let's find the angle that's being bisected, angle EDG. So that's this whole big angle right there. So that means this guy right here is going to be congruent to the other little guy. But you have to make that conclusion yourself. So you have to come out and say angle EDF is congruent to angle GDF, and that's because the definition of an angle bisector. So notice we were given an angle bisector and we used definition of an angle bisector. Now we want to look, do we have one of our triangle congruences? I definitely think we have one, so we're ready to say the triangles are congruent. And I'm thinking we got a side, we got an angle, we got another side, we have SAS, SAS. All right, last question. Let's see, I'm going to zoom in a little. To support a tree, you attach wires from the trunk of the tree to stakes in the ground as shown below. The wires segment JL, I'm going to mark that, are congruent to segment LM, are of equal length. Use mathematics to explain how you know that angle JLK, which is this guy, is congruent to angle MLK. Okay, so I'm not marking them, I'm just putting question marks there. So here's how I would approach this problem. The tree forms a right angle with the ground. Okay. I'm sorry, I put my question marks in the wrong side. The question mark should go angle JLK. Up here, how do we know that those are going to be congruent? So the tree forms a right angle with the ground, which means, so measure of angle LKJ equals 90 degrees, and so does LKM. So we can say that. Because the tree is going to be perpendicular to the ground. So the tree forms a right angle with the ground. So we know that those were the 90-degree angles. Okay. Then, by right here, the tree trunk is congruent to the tree trunk. So then by reflexive property, of congruence, and I'm just going to use the congruence symbol. Segment LK is congruent to LK. And that is actually going to be the leg of our triangle, and they've already told us that, so by the given, because they already told us, by the given, segment JL is congruent to segment ML, and those are our hypotenuses. I'm just going to abbreviate hype. So then, by HL congruence, triangle JKL is congruent to triangle MKL. And then, by CPCF, we know that angle JLK must be congruent to angle MLK because they are corresponding parts of congruent figures. Okay? So notice it says you can write a paragraph proof or a two-column proof. This would be a paragraph proof. Okay? So that concludes your practice test. Again, you get what you put out of it. If you did the problems on your own and then checked, great. If you followed along and then filled in as you go, great. But I highly suggest that you either watch it again if you need to or see me with questions.